My dear friends, welcome to Rajashekar classes on Applied Data Science with Python. This is lecture number 88. In this lecture, I will continue my discussion on covariance. When you talk of covariance as a measure of the relationship between two variables, covariances have one drawback in that they are hard to interpret. Covariance values are not scaled to be within any specific range. So you can't really compare them across pairs of variables, which is why we often use correlation as a measure of strength of relationship. I will discuss what is correlation in my next lecture, that is in lecture number 89. If you observe this property, covariance of x comma y may not be equal to x dash comma y dash if x represents heights in centimeters, y represents weight in kgs, whereas x dash represents heights in feet, y dash represent weights in lbs. Means I am converting this centimeters to feet, kgs to lbs. Means covariance is altered. Covariance is affected by metric which you choose. I will discuss about this by taking one numerical example in my future classes. Time being, let me proceed further. Let me continue my discussion on covariance. Let me say x represents heights of students and y represents weights of students. I am interested in identifying relationship between x and y. Relationship means what? Maybe x increases, y may increase, x increases, y may decrease, or there may have any relationship which can be identified with the help of covariance. If you observe, there are, let me say like this, there are three measures to quantify such a relationship. They are, first one is covariance. If you read the term, it has got some similarity with variance. How will it be? We will try to understand. Second one is Pearson correlation coefficient. Third one is Spearman rank correlation coefficients. These are three measures which are used to identify or quantify the relationship between two variables. We will try to understand other two measures, means Pearson correlation coefficient and Spearman rank correlation coefficient, in my future lectures. Let me concentrate on covariance. I already discussed what is covariance in my previous lecture, that is in lecture number 87. If you write formula for covariance, formula is covariance of x comma y equal to 1 by n. What is this? This n represent, there are n pairs, n pairs of observations like x1, y1, this is first pair, x2, y2, second pair, maybe so on xn, yn. There are n pairs of values. That is 1 by n, sigma I equal to 1 to n. What is this? Sigma I equal to 1 to n, xi minus mu of x. What is this mu of x? It's a mean of x. Mu of y, it's a mean of y. Xi means x1, x2, so on xn. These are the values of capital X. Yi means y1, y2, so on yn. These are values of capital Y. This is simply covariance. If you observe carefully, just observe the formula for variance. What it says, variance of x equal to just 1 by n, same, sigma I equal to 1 to n, same, xi minus mu of x, same. Only there is a difference only in one term, that is instead of instead of yi minus mu y, here I have xi minus mu of x. Therefore, what can I say? If I say covariance of x comma y, instead of y, if I write x, what happens? 1 by n into sigma I equal to 1 to n. What happens? Xi minus mu of x into, again you will get xi minus mu of x. That is nothing but covariance of x comma x is essentially variance of x. I already discussed what is variance in my previous lectures. Sigma 1 by n, sigma I equal to 1 to n, x minus mu whole square we were saying. Instead of whole square, here I am writing xi minus mu of x into xi minus mu of x. Therefore, how can I say covariance of x comma x is variance of x comma x. This I already discussed in my previous lecture, that is in lecture number 87 theoretically. This is mathematical explanation of covariance and variance. Now, we will try to understand what is positive covariance. Positive covariance means this one. This is positive covariance. What does it mean? Covariance of x comma y. Positive means, what does it mean? If x is increasing, y is also increasing. Just observe this graph as I move from left to right along x-axis. What does it mean? X is increasing. Just see height here. Just see height. Is it not increasing height? This as I'm moving from left to right, x is increasing. This height is also increasing. Means as x increasing, y is also increasing. Therefore, that's what it says. If x increases, y is also increasing. Therefore, if you get some pattern like this, if I have pattern like this, I can understand that is a positive covariance. We will try to understand this with geometrical interpretation. How will it be? Just see this geometrical interpretation. Let me say this is my formula. What is my formula for finding covariance? Covariance of x comma y equal to 1 by n into sigma I equal to 1 to n xi minus mu of x into y I minus mu of y. Anyway, here n is number of observation. It is always positive number, 1 by n. What about this xi minus mu of x into yi minus mu of y? Just this is positive covariance. That's what we discussed in previous slide. Let me take one particular point on this pattern. Let me say this is x1, y1. If it is x1, this will be x1. This will be y1, isn't it? It's simple elementary mathematics. If you have x1, y1 point here, this represents x1, this represents y1, isn't it? Therefore, what I need, anyway, this 1 by n is positive, x, let me consider I equal to 1. I equal to 1 means x1 minus mu1 into y1 minus mu y. That's a mu1. It's not mu1, it is mu x. Let me say this is mu of x, this is mu of y. Now what happens? What happened here? x1, this is x1, this is y1. I need x1 minus mu of x. This is x1 minus mu of x. x1 minus mu of x, it's a positive number. x1 is bigger than mu of x. Even y1 minus mu of y, this is y1, it's a bigger than mu of y, it's a positive. Positive into positive, it will always yields positive results. What does it mean? 1 by n is positive, x1 minus mu of x is positive, y1 minus mu of y is also positive. This entire summation is positive, means at x1, y1 you are getting positive value. Just consider another point x2, y2. Just say this is x2, y2. If it is x2, y2, this is x2, this is y2. What happens here? If it is x2, y2, I must say I equal to x2 minus mu of x into y2 minus mu of y, isn't it? x2 minus mu of x, this is x2 minus, x2 is smaller than mu of x, therefore x2 minus mu of x it's a negative number. Again, y2 minus mu of phi. y2 is smaller than mu of phi. Therefore, y2 minus mu of phi is also negative. Negative into negative, it always yields positive results. Therefore, at x2, y2 is also you are getting positive number. If you take x3, y3, what happens? x3 minus mu of x, y3 minus mu of phi. This is positive. This is positive. Sorry, this is negative. Why? Because x3 is smaller than mu of x, y3 is smaller than mu of y. Negative into negative, you will get positive value, isn't it? If you can understand, if you take any point on this pattern and if you calculate, you will get positive values. If you take points so far away from mu of x and mu of y, this value keeps on increasing. Therefore, what does it mean? If there is a pattern of this type, just if you calculate covariance, you will get positive covariance. That is, as x increases, y also increases. Now, we will try to understand what is a negative covariance. Just see, this is the case. What does it mean? As x increases, y decreases. Just see, here y height, this y height is y, isn't it? Is it not decreasing height? Height is keeps on decreasing, isn't it? Therefore, what does it mean? As x keeps on increasing, as I am moving from left to right, as x is increasing, this height is decreasing. Therefore, this is known as negative covariance. Even you can understand geometrically how this negative covariance occurs. Just the same explanation anybody can understand. This is my covariance formula, 1 by n. Anyway, n is number of observation is positive number. Let me take this is x1, y1. This is my x1, this is y1, this is, let me say, mu of x, mu of y. What does it mean? x1 minus mu of x. x1 is bigger than mu of x. x1 mu of x is positive. x1 minus mu of x is positive. y1 minus mu of y. y1 minus mu of y. y1 is smaller than mu of y. Therefore, it is a negative number. Positive into negative will get negative quantity, isn't it? In similar manner, just take x2, y2. There is another point x2, y2. This is x2, this is y2. What happens? x2 minus mu of 2. That is, x2 is smaller than mu of x. x2 minus mu of x. That is a negative number. Again, y2 minus mu of y. y2 is bigger than mu of y. Therefore, you are getting y2 minus mu of y as a positive. This is negative. Negative into positive is always, it yields a negative results. In this case, you will get covariance between x and y. If you take sum of all these products, you will get a negative quantity. This is, I can say, this is geometrical explanation of covariance. Just try to go through this lecture. This is simple and useful lecture. Thank you very much.